Hello dear students, this is lecture 15 and in this we will discuss about dot product and cross product of vectors, and we'll also study a little about horizontal projectile. So the first topic of today's lecture is dot product or scalar product of two vectors. Dot product always results in a scalar quantity if we are having a and b vectors in component form as given. Then a dot b can be written as corresponding multiplication of their components like ax bx, ay by, and az bz. Ijk's are eliminated in dot product and the result is a scalar quantity. Let us take an example. For example, a is equal to 2i plus 3j plus 4k and b is equal to 3j plus 4k. Please note here there is no x component, hence I is not there. Do not get confused here. So we need to find a dot b. So a dot b can be calculated by the formula corresponding terms 2 from here and here it is not there, so 0. Then 3 from here and 3 from here 9, 3 into 3, and 4 from here and 4 from here, that is 4 into 4. So ax bx ay by az and bz. As bx is equal to 0, this is 0, so it is 25. So it is a scalar quantity, no ijk, a dot b is equal to 25 units. In magnitude form, if magnitude of vectors is given and angle between them is given, formula of a dot b is ab cos theta. There are few special cases as per this formula, like when vectors are parallel, their dot product must be equal to AB, individual product of their magnitude, because when they are parallel, angle is 0 and we know that cos 0 is equal to 1, so A dot B becomes AB. And similarly, when the vectors are perpendicular, A dot B is equal to 0, because we all know that cos 90 is equal to 0. When two vectors are anti-parallel, it means angle is 180 degree and cos 180 is minus 1, so A dot B becomes minus AB. Next is cross product. In cross product, result is always a vector quantity. Again, let us consider if A is a vector like axi plus ayj plus azk, and B is a vector bxi, byj and bzk, then cross product is represented by this determinant where we write ijk and then we write the components of first vector. The position is very important. If you will write components of b factor first, then your answer will not come same. Cross product is not commutative, which means a cross b is not equal to b cross a, and then we write for b. So first we write for the first vector and then we write for the second vector. Then there is a tricky way to solve this. For solving this, what you have to do, you will write it like I'm explaining. First you will write the I from here, and then you will hide this column and you will hide this column, and then you follow this routine. Ay into bz, here it is, minus by into az, here it is. Okay, similarly we can go for the second term. We write j, and there is a minus always, so there is a minus with j always, not with I and not with k. The reason you can understand later when you will study in your mathematics determinants. So for j you can remember it's always minus. Again we can hide the I, this column and this row, and we can write like ax bz and then bx az and then j. Similarly we will write the k term here, and then we can hide this column and we can hide this row, and we can write like this: ax by and bx ay. So you remember this, go through this, repeat this video, and try this again and again. It is a little tricky. I is always positive, j is always negative, and k is again positive. and then you do this thing, hide the column and write the cross multiply in this order only, first product minus second. Similarly, then you will hide j column, you will write ax bz minus bx ay, then you will hide k column and you will write ax by minus bx ay. Let us also solve a numerical for understanding it better. Let us consider a vector A is equal to 2i plus 3j plus 4k and a vector B is equal to I plus 2j plus 3k. Then find A cross B. So we have arranged in the same manner. A cross B is equal to ijk we have written. Then because it is A cross B, we will first write the coefficients of A 2 3 4, then we'll write the coefficients of B 1 2 3, and then repeating the same operation. After writing I, hiding I column, 3 into 3 minus 2 into 4, then hiding j column and row, 2 into 3 minus 1 into 4, 2 into 3 minus 1 into 4, then hiding k column, 2 into 2 minus 1 into 3. So here it is 2 into 2 minus 1 into 3. So after solving it like this, we got that the vector result A cross B is I minus 2j plus k. There is one more important thing about direction of A cross B. Consider this is A and B vector in plane of your mobile screen and you are finding out A cross B. Then A cross B, if you imagine a screw here and you are rotating it clockwise, it will go perpendicular into the plane of paper. So A cross B direction is perpendicular into the plane of paper. This is into, because I cannot show 3D, so that's why I have shown like this, into plane of paper. And if you are evaluating A cross B like this, that you are moving in anti-clockwise direction, if you imagine a screw here and you rotate it anti-clockwise, it will open up and it will come towards you out of screen. That direction is shown by this. So what you have seen that in A cross B and B cross A, the magnitude is same but the direction is reversed. Hence your A cross B is equal to minus B cross A. So this product is not commutative, while dot product is commutative, which means A cross B is equal to A dot B is equal to B dot A, but A cross B is not equal to B cross A, but A cross B is equal to minus B cross A. माइनस साइन एक्स्ट्रा हमारा आ जाता है. जैसे हमारा डॉट प्रोडक्ट में मैग्नीट्यूड फॉर्म के लिए फॉर्मूला था A डॉट बी इज इक्वल टू ए बी कोस थीटा, ऐसे ही हमारा क्रॉस प्रोडक्ट का मैग्नीट्यूड और एंगल की फॉर्म में फार्मूला है A क्रॉस बी इज इक्वल टू ए बी साइन थीटा एंड देन सी यूनिट वेक्टर. क्योंकि वेक्टर प्रोडक्ट का रिजल्ट तो हमेशा एक वेक्टर है, तो मैग्नीट्यूड के साथ यूनिट वेक्टर आना ज़रूरी है. ए बी साइन थीटा हमारा मैग्नीट्यूड है और सी हमारा यूनिट वेक्टर है, जबकि डॉट प्रोडक्ट के अंदर सिर्फ मैग्नीट्यूड आना था, तो इसीलिए ए डॉट बी ए बी कोस थीटा होता है. क्योंकि डॉट प्रोडक्ट का रिजल्ट स्केलर होता है तो हमें उसके साथ यूनिट वेक्टर नहीं चाहिए. अब जैसे हमने डॉट प्रोडक्ट के अंदर कोस के एंगल 0 और 90 और 180 का केस कंसीडर किया था, ऐसे ही हमारा पैरेलल वेक्टर्स के लिए केस है. अगर हमारे वेक्टर पैरेलल या एंटी पैरेलल है, यानी कि 0 डिग्री और 180 डिग्री बोथ, तो हमारा साइन 0 हो जाएगा, तो A क्रॉस B इज इक्वल टू 0. एंड इफ़ द वेक्टर्स आर परपेंडिकुलर, तो हमारा जो A क्रॉस B का मैग्नीट्यूड है वो ए बी के इक्वल आ जाएगा. ऑल्सो जो A क्रॉस B का मैग्नीट्यूड होता है वो एरिया ऑफ पैरेललोग्राम के इक्वल होता है. आई विल एक्सप्लेन इट टू यू हेयर. सपोज दिस इज A एंड दिस इज B, then A cross B is equal to area of this parallelogram. A cross B is the area of parallelogram formed by sides of your vectors whose product is being taken. Or you can also say that the A cross B is equal to half of the area of the parallelogram. So if you will do A cross B magnitude divided by 2, you will get the area of triangle. And if you will write A cross B, you will get the area of parallelogram. A cross B, you will get the area of parallelogram. I have shown it in blue. And A cross B by 2 is the area of triangle. I have shown in black, and also shaded the area of triangle in black and complete parallelogram in blue. So after studying this, let us have one more example of cross product. Find the magnitude of torque of a force, that is F is equal to minus 3I plus J plus 5K Newton acting at a point 7I plus 3J plus K meter. We know that torque is equal to R cross F. So evaluating R cross F, and please pay attention here that torque is equal to R cross F, hence we will write the coefficients of R first and F second. If it would have been F cross R तो हम F पहले लिखते और R बाद में, और इसके बाद हमने इसको ऊपर वाले तरीके की तरह इवेल्युएट किया सेम वे में, hiding I 3 into 5 minus 1 into 1 I, then hiding J 7 into 5 minus 3 into 1, so 35 plus 3 it will become, and there is minus sign with J always, and then hiding K 7 into 1 minus 9 to 7 plus 9. So you will get this vector torque is equal to 14I minus 38J plus 16K. And for finding the magnitude of torque, we know this formula by components of a vector in 3 dimension. So 43.54 Newton. So after this, next derivation is from 4th chapter, that is motion in a plane, projectile. So first we must understand what is a projectile. A projectile is a name given to a body thrown with some initial velocity with horizontal direction and then allowed to move in 2 dimensions under the action of gravity alone, without being propelled by any engine or fuel. There are so many examples of projectile, like हम कोई पत्थर फेंकते हैं छत से नीचे, water jet और cannonball, bullet fired. All these are examples of projectile. For studying projectile, we do few assumptions. And before assumptions, I would like to point out that it is not propelled by any engine or fuel. It is under the action of gravity alone and given initial velocity only. So your missiles, rockets, jets, aeroplanes, all they do not came under category of projectile. In projectile category came like cannonball, bullet, जिनको initial velocity given है, water jet, and any object thrown at some angle with the horizontal or vertical. Few assumptions we will made in this lecture. There is no frictional resistance of air. The effect due to rotation of earth and curvature of earth is negligible, and acceleration due to gravity is constant and in magnitude and direction at all the points of motion of projectile. So we will start with the horizontal projectile. Consider this is a platform whose height is h and a projectile is thrown with velocity u in horizontal direction. So we are representing by UH the initial horizontal velocity and by UV initial vertical velocity. Dear students, this horizontal projectile or projectile motion composed of 2 motions. One motion is the horizontal motion and the other motion is the vertical motion. As vertical motion is under the effect of gravitation, it is your uniformly accelerated motion with acceleration is equal to g. So we apply our equations of motion for vertical motion. But please pay attention, for horizontal motion, it's uniform motion with zero acceleration. Hence we apply simple equation for horizontal motion. Distance is equal to speed into time. So it is combination of 2 motions, one is uniform and other is non-uniform. So first, studying vertical motion, when object is coming down, you can see initial vertical velocity is 0 and final vertical velocity, let us say v, and the distance is h and acceleration to gravity is g. Using these details and applying equation s is equal to ut plus half at square, as vertical motion is uniformly accelerated motion, so I will use equations of motion. I can easily figure out that putting u0 and h as a distance and g as a, the time of flight is root 2h by g. So time of flight is calculated, and if you know the time of flight, then your horizontal motion is uniform motion. The range is simply time multiplied by the horizontal velocity. One more thing I would like to show you here in this projectile. Horizontal velocity is constant and same throughout the motion. It will not change. While vertical velocity starting from 0 will increase a little, then increase even more, then increase even more. because vertical motion is uniformly accelerated motion, but horizontal motion is uniform motion. In horizontal motion, velocity remains constant. In vertical motion, velocity will increase. So calculating range by this simple formula, that horizontal velocity which is constant into time, this is equation for uniform motion, we got the range. Okay, so thank you for today's lecture. In next lecture we will start with the angular projectile, and we will also discuss one example of your horizontal projectile numerical example. Okay, take care, bye.